In this video, we're going to be looking at the October-November 2024 paper 12 question 6 problem. And wow, it looks a little bit hectic, right? So you've got like a very weird shape here. We've got 2 theta radians, which means this angle over here is double that angle. This one is the same. We've got this radius. We've got arcs everywhere, right? And then this is going to be 2r. I don't know if it's this length that's 2r, if it's the full thing that's 2r, but we'll read the question, right? But clearly, this looks like a circular measure problem. And moreover, right, the moment you see, if you're looking at this question, the moment you see this word, radians, what do? Change your calculator settings to radians, right? So just make sure before you go any further, just make sure that your calculator is set to radians instead of degrees. All right, let's go. So the question says, the diagram shows a metal plate. All right, let's just erase this. The diagram shows a metal plate, O, A, B, C, D, E, F, O, right, consisting of sectors of 2 circles. Each circle with a center, O, okay. The radii of sectors O, A, B, and E, O, F. So this sector and this sector have radius are centimeters. Sorry, I confused myself there. All right, cool. So let's just to avoid confusion, let's just make sure we mark those, right? So this line, this, and then this line over here, right? So we've got r centimeters, you've got theta radians. We have this other one, which is exactly the same. Can I actually arc these? No, it's going to draw a line. And then this line over here, again, it is a sector with radius r and angle theta radians. All right, cool. And then we have, where do we stop? Okay, and the radius of sector COD, so the COD is 2r centimeters. So it's this 2r, that's the thing that I was trying to figure out, right? Is this 2r for this, or is it for the full thing? And they've just told us that it's for the whole sector. So which means this sector over here has radius. Let me just move it to the side a little bit. Has radius 2r. All right, with that sector over there. Nope, didn't work. Okay, so that also tells us a couple more things as well, right? So before we move forward, it also tells us, we also know that this line over here, we know that from here right up until the end over here, that's also r centimeters because it's the same sector, right? So this radius is also equal to that radius. Same thing on this side as well. From O to E is also going to be r centimeters, right? And since this full thing is going to be 2r, it's 2 times r, which means this from here up until here. Maybe let me just draw it like this. From here to here, this is also r centimeters. And then this is also r centimeters. From there to there, that's also going to be r centimeters. All right, that's what that tells us. All right, just some extra piece of information which may or may not be useful. Okay, it is given that the perimeter of the plate, actually no, we haven't finished. Angle AOB is equal to EOF. AOB is equal to EOF. Perfect. And then angle COD is 2 theta radians. Perfect. It is given that the perimeter of the plate is 14 centimeters, right? So let's just highlight that. Perimeter of the plate is 14 centimeters. Maybe let's make that thicker. All right, and it is also given that the area of the plate is 10 centimeters. Okay. And also r is greater than 1.5. Theta is smaller than 3/4. Find the values of r and theta. All right, so we have a lot of unknown values here, right? But what we have been given is that perimeter is 14, area is 10. So maybe let's make that our starting point. Okay, so how do you find perimeter, right? In order for us to find perimeter of the entire shape, we'd have to take the different sides of the shape, right? So we have to take this first side, which is OA, that's going to be R, plus we have to take the length of this arc of AB, which is going to be, let me just call that arc AB, plus we need this line over here, which we said was R, so that actually came in handy. We need the length of the arc CD. We need DE, which is R. We need arc EF, which is the same as arc AB. From that arc, we then come right back down where we started, which is going to be FO, which is R. All right. So the only two, the three things actually that we don't know are AB, this one, and that one. So we need to find the equations of those. So how do you find the arc length? We know that the formula for arc length S is equal to R multiplied by theta. Okay, so for each of those, right, so we can rewrite this formula as perimeter, which we know is 14, right, is equal to the radius plus arc AB is the arc of this little sector over here. And the radius of that sector is going to be R, the theta is theta. And then plus R plus arc CD. Again, this is going to be R multiplied by theta. So we have to ask ourselves, for that sector, what is the radius? And we know that the radius is 2R. That's going to be 2R multiplied by, in this case, what is the angle of the sector? It's going to be 2 theta. Perfect. Plus R plus arc EF, which we know is the same as this one. So that's also going to be R theta and then plus R. So we can simplify this. Let's simplify this a bit further, right? So we can see that we just now have an equation with unknown values R and theta. So we just need to simplify those, right? So let's group our like terms. We're going to group the terms with R. That's going to be this term, that term, that term, that term with just R's. So how many do we have? We have 4 of them. So we're going to add those to give us, so R plus R plus R plus R gives us 4 R's. Plus we have R theta plus R theta is going to be, okay, let's actually just to avoid confusion, R theta plus R theta plus, I want to simplify this. 2 times 2 is 4. And then we have R times theta, which is R theta. So these two, even though they look different, I mean, these three, even though they look different, they're actually the same. They're like terms because they're all terms with R theta. So now we can add those 3 terms. So we still have a 4R, but now we have R theta plus R theta, which is 2R theta. Add another 4R theta, we get 6R theta. All right, and if you want to factor out your R over here, if you want to just make sure that there's only one R in the equation, you can factor out the R and you're left with 4 plus, because we removed an R here, we're left with the 4. If you remove the R from here, you're left with the 6 theta. Okay, perfect. That's our equation, right? We might need to use it in this form, we might need to use it in that form, whichever one we will see, along the way. So that's what we did with perimeter. We took the equation and we simplified it. We're going to do exactly the same for area. All right, so for area, we're going to say, okay, what is the equation of area? I mean, the formula for area, right? So the formula for area is actually the area of a sector is equal to half R squared theta. So again, we found ourselves in a situation where all we need to know to get area is the radius and the angle in radians. So how many areas do we have in our shape, right? So we have this area over here. We have that area over there. And then we have this area over here. We have 3 separate areas, right? So let's take each of those areas and then add them up. Or at least let's find the formulas of those areas. So the area of the first sector, which is sector AOB, let's just write those out actually. Area of AOB plus area of COD plus area of the sector EOF. All right, perfect. And then area of AOB A over B is going to be half r. Now what's the radius? The radius is just r. So we're just going to write it as r squared. And then what's the angle of the sector? It's going to be theta. Plus, same thing over here. It's half r squared. Now, what's the r? What's the radius of that other sector? The radius of that sector is actually 2r. So remember, it's r, the radius squared, multiplied by the angle, theta. The angle in this case is 2 theta. That's going to be 2 theta. Plus half, this one's actually the same as that one, so we know that we can just write it like this. But again, it's half of the radius, which is r, multiplied by the theta. I mean, the radius squared, which is r squared, and then multiplied by theta, which is just theta. All right, again, we are going to group our like terms. We're going to simplify and group our like terms. So we've got half r squared theta. Since these are the same, I'm actually going to write this as multiplying by 2. Or maybe that's confusing. Okay, it's fine. Let's just leave it like that. Plus half of 2r squared gives you 4r squared. Because remember, your squared applies to both of the terms inside. Since they're multiplying, you can square them individually. So 2 squared is 4, r squared is r squared. Multiply this by 2 theta. And then you still have your half r squared theta. That, by the way, is equal to the area, which we know is 10. So we can just write 10 on this side. And then, so we have half r squared theta. I'm going to take this one and write it next to this one because they're the same. Plus another half r squared theta. Plus, now, half of, so I'm just going to take these numbers. 4 multiplied by 2 gives you 8. And you multiply it by half, which gives you 4. So you're left with the 4 over here. And you still have your r squared. You still have your theta. All right, nice. We've simplified it a little bit. So now we have like terms because each of these terms has a r squared theta, r squared theta, r squared theta. So that means now we can take those numbers and add them up. Or if you want to think about it this way, you can say, okay, r squared theta is the common term here. So we can factor it out. And then what you're left with each term is over here, you're left with a half. Over here, you also left with a half. Over here, you're left with a positive 4. So what we have is half plus half, which is 1, plus 4, which is 5. So we have 5r squared theta. All right, we can actually divide both sides by 5 to cancel it out on this side. And then over here, you're left with 5 over 10, which gives you 2. So r squared theta is actually equal to 2. All right, so we've got our second equation, right? Remember, the goal for this is to find r and theta. We have 2 different equations here. 2 different equations, each of them has 2 unknown values. And so basically, what we can do in this case is just trying to work this out. We can just use simultaneous equations, right? So 2 equations, 2 unknowns, that is a simultaneous equation. So what is the best way to get the simultaneous equation? I am going to take this r. Okay, I'm trying to figure out what, essentially, should I substitute the r from here into this equation, or should I, take a theta from that equation? So I think I'm just going to jump straight, there's different ways that you could do this. You should come up to the same answer. I'm just trying to cheat the system by trying to figure out what the easiest way of going about this is. So I'm just going to jump into it, right? So this one, it looks like there's a theta here. That's easy to access. So I'm going to write this as theta is equal to 2 over r squared. Right, from there, we then substitute that into the first equation, right? So these are your simultaneous equations of a quadratic equation, So yeah, it's never going to be easy. It's never going to be like simple and straightforward, I guess, if I should say. So once you take that, you then put it back into the equation 1. So equation 1 becomes 14 is equal to r multiplied by 4 plus 6 theta. 4 plus 6 theta. But now your theta value is actually 2 over r squared. So we're going to write this as r. I'm going to write the big brackets this time. 4 plus, instead of saying 6 theta, you're going to say 6 times 2 over r squared. So now we have one equation with just r's, right? So we can solve this. So what we're going to do is we can, so this is where I was trying to gauge to see what the easiest thing, because we're going to come up with a quadratic probably, but let's see. So we're going to multiply the r back in, so that's going to be 4, r times 4 plus r multiplied by 6 times 2, which is 12. But remember, we have this r that's coming in, that's multiplying here, but we still have the r squared on top. I mean, at the bottom. So one of these r's can cancel with one of these. So now you have 14 is equal to 14r plus 12 over r. Okay, now what we don't want to do with equations is have a denominator that has an unknown value. So in order for us to get rid of this, we are going to multiply this by r, which is going to cancel this. Perfect. But remember, you have to, whatever you do to this term, you have to do to this term, and you also have to do to that term. So our equation is going to turn into 14r is equal to this. Oh, shucks, this is not supposed to be 14. And these are the small mistakes that we make, or at least that I make. All right, so this one is now 4r squared and then plus 12. Nice, right? These are all even numbers, so I think I'm going to divide each of these by 2. So this is going to become 7r is equal to 2r squared plus 6. Can't really, there's no other like terms here. So now this just becomes a quadratic equation. So for quadratic equation, you want everything to be on one side. So we're going to take the 7r to the other side to leave this side as 0. So now you have 2r squared minus 7r plus 6. So I don't have one of those fancy calculators where you just plug in things, right? So I am going to take this and say, okay, what's my a value? I'm going to do it the old school way. My a value is 2, my b value is negative 7, my c value is positive 6. This is also positive. So that means that if I want to work this out and find r, I would say negative b plus minus the square root of, what is it? I think it's b squared minus 4ac divided by 2a. That's equal to negative b is negative 7, which is positive 7, plus minus the square root of b squared, which is 7 squared, that's 49, minus 4 times a, which is 2, times c, which is positive 6. 4 times 2 is 8, times 6, 8 times 6 is 48. Oh, perfect. 49 minus 48, that's 1. All right, multiplied by 2 times a, which is 2 times 2. All right, and then from here, this is the point where I just plug it into my calculator. But I'm going to plug in 2 separate cases. The case where this is positive, and the case where it's negative. When it's positive, I get 49 minus 4 times 2 times 6 divided by 4. I get a value of positive 2. When that value is negative, so I'm going to go back into my calculator, I'm going to go to the same equation and change the positive to negative. I get 3 over 2. Positive 3 over 2. So those are the two answers of radius I get. So now the question is, what is the answer? Which of those two do I get? Because if the answer had been a negative, it would have been easy because radius can't be negative, but both of these are positive. So what do we do, right? We have a restriction though. Remember, our solution said r has to be more than 3 over 2. We have an r is equal to 3 over 2. So that means that doesn't qualify. So automatically it means this is wrong and this is correct. Hopefully, as far as like our two options go. So our radius is actually supposed to be 2 centimeters. Perfect. That means we can take this 2 centimeter value and we're going to go to theta. Theta is equal to 2 divided by radius squared. Now we know that our radius is 2, right? So that's going to be 2 divided by 2 squared, which is 2 over 4. And that answer is a half radians. So half a radian. Just make sure that it follows the same restriction that we got. And it said theta had to be less than 3/4. Perfect, right? So half is less than 3/4. That means this should be fine. Right, I will check. I always check the marking scheme once I'm done just to make sure I didn't make any mistakes. But these two answers follow our restrictions, so that is perfect, right? If we had put this 3 over 2 our theta would have been 2 over 1, 1.5 squared, which is, shouldn't really matter, but 8 over 9, which is greater than 3/4. So neither of these two answers, this and its theta counterpart, followed the restrictions. So our two answers are going to be radius is equal to 2 centimeters and our theta is equal to half a radian. All right, perfect. Right, okay, that was a tricky one, but hopefully as we're going through these questions, you're seeing how even if you get this, right, so you shouldn't be intimidated when you see a complex graph here, right? You should expect it, right? Because, they like to throw these things at you, but you have the tools to break it down, because all we needed to do for this question is to know what the area formula is, and what the arc length formula is. And the rest of it is just, write it down, see what you don't have, and use those formulae to work out what you don't have. So hopefully as we're going through these questions, you're kind of getting more used to how to break down these more complex questions. Okay, perfect. We're going to end the video right here.